So welcome to our demonstration for wafer and chip level photonic test, shown with a new manual probe station from FormFactor. The need for high bandwidth interfaces with high density and low power consumption, especially in the data centers, was driving rapid development in photonic integrated circuits. This PIC technology, often labeled as silicon photonics, also offers functionality that can be used for quantum computing, automated sensors for the automotive and medical industries, as a few examples. This rapidly expanding technology raises challenges for test and measurement, both during development and production, so that processes can be monitored and corrected, and defective components can be identified at an early production stage before incurring additional cost. Here we are showing a configuration of Keysight's offering for testing PIC devices, focusing on the parametric optical measurements that can be made at an early stage of production or packaging. This measures fundamental parameters like the attenuation of waveguides, responsivity of photodetectors, and their dependence on optical wavelength and polarization. The wavelength dependence provides details like resolution and free spectral range for filters and resonators and modulator structures. The radio frequency dependent response and thus bandwidth of devices like modulators and detectors can also be measured. These measurements are greatly aided by the advanced functionality for analysis functional polarization dependence, for instance to separate TE and TM characteristics, and also automatically align the polarization with the axis of the device. The system combines one or more tunable lasers with a polarization controller and a variety of detectors. An optical power meter is used here for measuring devices with optical output like waveguides and modulators. Aligning the fiber probes is also supported with the analog output that provides a feedback for signal optimization proportional linearly or for covering a wide dynamic range logarithmically to the optical power. For devices with integrated photodiodes, the photocurrent can be detected in a similar way using source measure units, shown here in a PIXI module format. Also shown here is a PIXI vector network analyzer to measure the optical modulation that can be applied via an RF probe from the VNA. Higher levels of automation combining several measurements and workflow steps can be supported with the Keysight test automation software, for which plug-in drivers have been developed to automate the Lambda scan software, optical RF measurements, and FormFactor probe station.